a system of inequalities. And inequalities mean we're going to graph a shape. It's not just going to be a dot. It's going to be an area. And so like on here, we have two equations. We have x minus 2y is less than 6, and y is less than or equal to negative 3 halves x plus 5. Now I want you to talk about the first equation. You notice the first equation is less than. Correct? If it's less than, what kind of line? First of all, what kind of shape is it? It's a line, okay? Is it going to be a dotted line or a solid line? Dotted. Dotted. There's no equal sign. Now, on the second one here, again, it's a linear equation. It's a line. But this one has an equal sign underneath it, right? So that's going to be a solid line. So we have to make sure we know the difference between this solid and a dotted line. Because the equal sign is to be solid. Now, the first equation I might have to try to get by itself. I'll get y by itself. So I'm just going to go off to the side here and solve this one down here. I'm going to have x minus 2y is less than 6. I'm going to subtract x. So I'm going to get negative 2y is less than negative x plus 6. Anything I do wrong? Get negative 2, right? Now what? That sound about right? I divide by a negative, I divide or multiply by a negative, I flip the sign. Correct? I divide and multiply by a negative, I flip the sign. I don't have to worry about it if I go back to the original equation, but it's just a reference when you do state testing. If you divide or multiply by a negative, you're going to flip the sign. Now I have two equations to graph. I don't care which way I graph them, but I'm going to graph them. The first one here I'm going to graph. Where would I start on this one?
Negative 3.
Negative 3. We'll start at negative 3. So I'm going to go down to a negative 3 and put a point. Now my slope here is 1/2. That means up 1 over 2. So I'm going to go up 1 over 2. Up 1 over 2. And I can keep going like that to get my graph. And you said on this first one here, is it going to be a solid or dotted line? Which one? Dotted, okay. As you speak up. I'm going to go here. A dotted line. Okay? Do you agree with me? Do I have to do shading yet? I have to do shading, okay? Now, what I have to do, this is my first equation. Which point would be a good point to try? Which point doesn't go through that line? 0. So let's go up here. 0 minus 0, which is? 0 is less than 6. True. Could I go down to this equation? Yes, I could. But I'm actually going to stay with this one right here. Bailey, you look confused.
Oh, yeah. Okay, you divide it by negative 2 over there.
Yep.
This one then would it be negative 3, and then you times by negative 1. So would that be?
I didn't. Well, okay, wait a minute.
You already get rid of the negative.
I divided by negative 2.
Okay.
Negative 1 divided by negative 2 is 1/2. 6 divided by negative 2 is a negative 3.
Oh, why did the sign flip then?
This flip?
Yes.
Because if I ever divide or multiply by a negative, I flip the sign.
Okay.
Okay?
Yeah.
So now I tried 0, 0 and it worked. So what am I going to do? Shade on that side. So I'm going to shade on that side. Let's go with this one. So I'm up here. Good? Now my second equation is this one. Where do I start on this one? 5, right? So I'm going to start at 5. So 1, 2, 3, 4, 5. Slope is? Negative 3 halves. That means what? Down 3. 1, 2, 3 over 2. Down 3 over 2. Down 3 over 2. Now, is that going to be a solid or dotted line? Solid. Solid line, so I'm going to use my solid line here. I should have arrows. This one didn't have arrows in it. On the end of this, and that one doesn't have an arrow on it. Like that. Okay? Which point would be easy, now not even thinking about the rest of the graph, which point would be easy to plug into this graph? 0, 0 again, because 0, 0 is right here. Correct? So if I plug in 0, 0 into this equation, 0 is less than or equal to, and this will be 0, 5. Is 0 less than 5? Yes. So I'm going to shade where that is. So I'm going to shade on this side the whole way down. Correct? Now where's my answer? Yeah, the both where they intersected. And you kind of have to be a little careful with these a little bit. Noticing that they are shaded right here. Okay? Does it include this line? No, it's dotted. Does it include this line right here? Yes, it's solid. So my answer is anywhere in here, okay, on this line works, but not on this line.
Why is it dotted?
Yep, dotted means it does. Dotted means it gets very close to that, but it's never equal to that. That's why we would not include those points.
So how would you write your answer?
My answer is this graph. The answer is the graph.
Oh,
I should be able to see your points, see that the line is dotted, see that this is a solid, and see where your shade overlaps. Okay? That's going. So, but understanding, if I ask you to try a point in here, if I said, is 0 a negative 3 an answer to both this system of equations? And I would say no, because it's on the dotted line. Is 0, 5 an answer to this system equation? Yes, it's on the solid line, it's okay.
So that has to be on the solid line.
It's on the solid line, it's shaded where it's shaded, and solid lines included, dotted lines not. Okay? Because this green area goes up to the dotted line, it includes that area. But now remember the solid line here, just for reference, when I say it includes the solid line, it includes the solid line from here to forever that way. It does not include the solid line down here.
So it includes the solid line until where it crosses the dotted line?
Yes. It only includes it where it crosses. Because once down here, are both of these shaded down here? It's only where it's shaded both. Okay? So it's only included the solid line up from that point. That makes sense?
So if both lines are shaded, it can't be on either one of them?
If both lines are dotted, then it can't be.
Yeah,
It can't be on either one. No, it's just the shaded region. Now we want to get used to doing these equations because I got 2 right now. And sometimes you might want to change your scales, you might want to use a little graph paper, whatever. Later on in the next section, we're going to be working on linear programming. We're going to have 6 equations. And we have to shade all the different areas. And we're looking for where they overlap. You know, this is just 2. Imagine going with 6 of them. It's going to be a very messy problem. So, okay, you try this one. These I don't have to solve the equations out too much. The first one's pretty easy to do. I always look at the equations and say, are they dotted, are they solid right away? So the first one would be solid. Solid. There's an equal sign underneath. There's an equal sign underneath it. Second one is dotted, and there's no equal sign underneath. So one's dotted, one's not, right? On the first one, what would I do? Start at a positive 4 up here, and the slope would be Down 2 over 1. So I'm going to start at positive 4.
Let's go back to
Okay. Started at positive 4. And my slope is down 2 over 1. And I'm going to draw my straight line in there. And you said this is a solid line, right? I'll have to fix that line a little bit. Okay. That look all right? Now in the shade. Now if we're going to shade this graph, what point would be an easy point to plug in? 0, 0. I like that 0, 0 point. 0 is less than 4. True. So we're going to shade where 0, 0 is, right? So, I'm going to shade this side. Agree? Now my second equation, what is my second equation? X is greater than a negative 3. What kind of equation, what kind of graph is it? Vertical line, right? Up and down. Vertical line going up and down. So it's at X equals a negative 3, and I got a negative 3 right about here. So this is going to be a dotted or solid line. Dotted line, so we're going to go to my dotted line thing here. And there's my dotted line.
You put it right on the
Right on a negative 3. It goes all the way, so it's always a negative 3. Because what this means is that my x value is always going to be a negative 3. That's all that means. I don't care what y could be anything, but my x is going to be negative 3. It doesn't change. That's why it's vertical. It's always a negative 3.
But it's like greater than.
But greater than means, I'll put it at negative 3, but it's a dotted, so it's never going to equal that. That's what the dotted means. Now, greater than, what side of the graph would I shade?
Oh, right shape.
I would shade the right side. That's what the greater than does. If I'm going to shade, that's a very crooked line. But good, and it's greater than. So what I'm going to do is shade the side that is greater than, right? So I'm going to shade over here. So what's my answer? So my answer is these points, correct? Including this line, not including this one, right? When I say what's my answer, what do I mean by that? If I pick any point inside that shaded area, or on that solid line, what happens?
It's true for both of those.
It's true for both equations.
It's not false.
So if I pick this point right here, let's say 0, negative 1. 0, negative 1. Negative 1 is less than 4. Right? Is that true? 0 is greater than a negative 3. It works, right? And I don't care what point I pick. I can pick 1, 1. 1, let's say 1 is less than 2. That's good. 1 is greater than negative 3. Now what happens out here, just kind of a reference here. Let's pick this point right here. This point is 1, 2, 3, 4. I'm going to pick a different color here. This point right here is 4, 0. Okay? The bottom equation was blue, the top equation was green, right? Which equation is this going to work in?
Bottom.
Bottom. 4 is greater than negative 3. Is that true? But if I go up to the top one now, I got 0 is less than negative 8 plus 4 is negative 4. Is 0 less than negative 4?
No.
Doesn't work in that top one.
That's false.
So that point doesn't work, but it doesn't work in the top one. If I pick the point here, what would happen? It's going to work in the top one, right? But it's not going to work in the bottom. And here it works in both. It's just the area, what you have. What we're looking for is the area part. It's a little different than finding just a point here. Actually, let's see. Let's do this one. Okay, top equation, dotted line or solid line? Dotted. Bottom of the equation. Solid. Bottom of the equation is what? Absolute value, so it's a B. Okay, now let's think how many people remember. Number inside. So it moves
3 to the
right 3 units. If 3 was on the outside, it would move, the negative 3 is on the outside, it would move it what? Down 3 units. But it's inside, so it's going to move to the right 3 units. What's my slope? 3. 1 over 1. It's the number in front of your x, so it's 1 over 1. So, if I was doing the, I'll do the absolute value first. I know my absolute value, the 3 is going to move it to the right 3 units. So I'm going to move it to the right 3. 1, 2, 3. Right here. And what I said right now is this is a positive slope of 1, right? Because the 1 in front of here is 1. So I go 1 on both ways. And I'm going to draw my line. And is it a solid line? Yes, it's a solid line, correct? So it's absolute value D. Shading. Which point? 0, 0 is the easiest point again. It's not going through there. 0 is greater than 3.
False.
False. So if 0 doesn't work, what do? Shade the inside. Now here's a little hint. When I'm shading the inside, notice I shade above it. Okay? I see a lot of people that go like this. They want to be really neat. And they'll shade up to the edge here and draw a straight line, shade down. It's like a little V, a triangle. It's like, it makes it look like it stops right there. Remember, it goes on forever. So I asked the question once, I had that little V and I asked the point above, no, it doesn't work. It's like, it goes on forever. It does go on, it's not just that little area. Okay, second equation, or the first equation in there, y is less than 4. Horizontal line through 4. Horizontal line through 4. So I'm going to go up here, do this one orange here. 1, 2, 3, 4. Here's my point. Dotted line or solid line? Dotted line. So go like that. Yeah. Yeah. There's my dotted line. Y is less than that, so I'm going to shade. Less than would be below, right? So I'm going to shade below that line. So I'm going to shade down here. So where's my answer? So my answer is shading. In there? All good?
Just that really small spot of green.
There. Does it include this line?
Yes.
Yeah.
Does it include this one?
No.
Yes.
Does it include that one too?
Yes.
Does it include this one?
No.
No. So it includes this line up to the dotted line.
Yeah.
Then it stops. Okay. That's all. That's all. Dave, solid or dotted? Both are dotted, right? First one starts at -1, and then the slope is down 2 over 1, down 2 over 1. And it's a dotted line, you told me, right? So, does it go through 0, 0?
No.
No, so we can shade on the 0 part of 0, 0. Now, I would probably, again, this is what I got. I still go back to the original question. Just in case I forget a sign or forget to flip, I always go back to the original equation. 0 is less than 2. Is that true? Yeah, so I want to shade the side 0, 0's on. So I'm going to shade this side. Okay. Second equation. Where do I start on the second equation? Start at 2. Slope is 1 over 1. Up 1 over 1. And you told me earlier it's a dotted line too. I put dotted line. Now the shade, again, a good point to plug in would be 0, 0. So 0 is greater than 2. False. So I'm not going to shade down here. I'm going to shade up above the line. So I'm going to shade up here. So my answer to this equation would be there's overlap right here, which is hard to see sometimes, not including this line and not including that one, right? So any point inside.
So do we have to say that, or can you just tell by looking at it?
A lot of people do is they just kind of do like I do scribble marks when it's shading, and when they have their final answer, they like take their side of their pencil and shade it real good, or real well. So it's like it's easy to see what it is. Other people bring a color pencil when their final answer, they just do it in a different color.
But like if we're shading that, you know that we mean that it's not, that we're not including these 2 dotted lines.
Yeah, you don't have to do the dotted line part. If I see the dotted line, I know it's not included. Okay.
I just wonder if we have to explain it.
Was that? Oh yeah, we can do. We got a lot of those. Yeah. Let's see. Oh, here's a good one. You want to bake at least 6 and at most 11 loaves of bread for a bake sale. You want at least twice as many loaves of banana bread as nut bread. So what do we got? We have 2 variables, right? So first thing we're going to do is write down our variables. We're going to say x is my banana bread. And y is the nut bread. Are they equal? Let's look at the sentence right here.
No.
Are they the same? You want more banana, right? So if I put here 2x, would that be right?
Because of these.
At least, okay, at least 2. Okay. If I take the number of banana breads and double it, let's think about it this way. Would they be equal now? This is a tough one. It says, but don't think about the least. Let's say we do want as many banana bread as nut bread.
Depends on how many nut breads you have.
So you want them to be equal, right? Let's make them equal. Is this equal?
It could be. Yeah.
Could be.
Okay, if I took the number of banana bread and doubled it. Now don't even think about it equation-wise. Let's just think about this sentence. Let's say I wrote down, I want twice as many loaves of banana bread as nut bread. Okay? I want twice as many. Which one's more? So if I didn't have the 2, are they equal?
No, I want,
Banana bread would be more, right?
yeah, greater.
Banana bread's going to be more because we want more banana bread than nut bread, right? So if banana bread was more and I put a 2 in front of it, is it going to be equal now? No. Okay, let's take it this way. Would this fall in the sentence?
No.
Is that twice as many banana bread as nut bread?
Yeah.
That worked, right? Now what I'm saying is this. If I put this to make them equal, if I put a 2 in front of this number, is it going to be equal? No. Where should I put the 2?
Why?
To make them equal. I want to think about how to make them equal. Now, if I put the 2 in front of the banana bread. So in other words, I want to think about equal always. I always start thinking about equal. Then I said, okay, if I had 8 loaves of banana bread and 4 loaves of nut, that's twice as many, correct? What would I have to do to get it to be equal? Times the y by 2, or double the nut bread, correct? It's kind of the opposite of what you're thinking. So yeah, I always, it's the easiest way. I started this about 2 years ago, 3 years, to always think about putting them equal to start with. Because everybody for the years has been trying to put the 2 on the x. Said, how do I make them equal? Now, do I want them equal? No, I want at least twice as many, right? I still want this one to be bigger, correct? Right now they're equal, so to make sure they're bigger, I want x to be greater than 2 what? At least twice, right? At least twice as many. You could do it in this one. I would accept either one on here. I'm usually very clear on the problem. At least could be equal there underneath there too. Now another equation is the first one. You want to bake at least 6 and at most 11 loaves of bread.
Why do people have to be picky?
Go with
Just
before.
make- just go with
X
two.
plus 2 y.
You need to know the ingredients. I made chocolate chip cookies. So I need to make sure I have the ingredients right. So I made mine for the other day too. So. Okay, what do we need? So
Cookies.
you know Jordan E. But the number of loaves are between 6 and 11. So what do we know about the number of loaves?
It has to be greater than 6 and less than 11.
At least 6. Okay, at least 6. So greater than
Greater than or equal to
6 and
Less than
equal to.
11.
Okay, I agree with that. What does?
X plus y.
X plus y. The number of loaves. I didn't say what kind of loaves, the number of loaves, right? So the x plus y, the banana bread and the nut bread together has to be. So how many equations do I have?
3.
Three.
Mr. Belthouse, please dial
I
520.
have this equation here, right? So I'm just going to put them down here. I have, if I want to write them out separately, I have x is greater than or equal to 2y, correct? I have x plus y, and this would be, if I wrote it this way, greater than or equal to 6, right? And then I have x plus y is less than or equal to 11. So I have 3 equations. Now, I don't care which way you do this. Solve it down, graph it. If I was getting y by itself on here, I would divide by 2 first. If I divide by 2, I'm going to run it backwards here. Y is less than or equal to 1/2 x, and I'm just going to put in here plus 0. Agreed?
Sure.
Plus 0 because I want my y intercept. So I know where to start in that one. That one's pretty easy to start with. If I was doing this one, either one of these, what would I have to do?
Get y by itself.
So I'm going to subtract x on this one. And I'm going to subtract x on this one. And so on this first one here, if I subtract x, I'm going to get y is greater than or equal to negative x plus 6. And here I'm going to get y is less than or equal to negative x plus 11. So I took all 3 equations, got y by itself, correct? Would you agree with that? Now I had to graph it. My first equation. Let's start with this one. Where do I start? 0. What's my slope? 1 over 2. So I'm going to go start at 0. I'm going to go up 1 over 2. And some of my graph might be hard to see here, but dotted line or solid line? Solid line. Should have used my straight edge. Okay. Can I try 0.00 on here? No. So what do I need to try? 1, 1. Okay. Somebody said this point right here. Oh, actually, 1, 1. 1, 1 would be right there. Would that be okay point to try? Okay. Let's try 1, 1 in here. I don't care. Let's go here. 1 is greater than 2. False. Agree?
Yes.
False. So I don't want to shade above, I would shade below. So I'm going to shade down here. I agree with that. Okay, next equation. Let's go this one. Where do I start? 6? What's my slope? -1 over 1. So I'm going to start at 6. My graph is very small, so my 6 is going to be here. Down 1 over 1. And it's going to be a solid line again, right? Right out of time here. Started at 6 and went down 1 over 1, right? Can I try 0.00 here? So 0.00, if I plug in 0, here, 0 plus 0 is 0 is greater than 6. So I want the other side here. So I want over here. Agree? My graph is getting messy. What's my last equation? Where do I start? I'm going to start at 11. So my graph is going to, here was 6, 7, 8, 9, 10, 11. So my graph, I don't have enough spaces on my graph, so I'm going to go like this. That's not a very good graph, but that'll work. Not a very good graph. That was very Try it again. That's a little better. Okay. What point can I try? 0, 0. Okay. 0 plus 0 is less than 11.
True.
Yeah. So I'm going to shade inside here. Okay. Now, where's my answer?
Over there.
Somewhere.
Over there.
It's like that
rectangle down here.
Almost all the colors.
Rectangle with the 6.
Okay, so you're saying
In there.
Yeah.
Yeah.
Ew.
Yeah. Yeah.
Yeah, because the red ones.
Usually all solid lines. Can I go all the way down?
You missed.
Yeah.
No, because then you have negative loads of bread.
I would have negative loads of bread. Can't go below the x-axis. So actually, there should be 2 more equations on here. 2 more equations should be that x is greater than or equal to 0, or y is greater than or equal to 0. It should be 2 more equations because you can't have negative loads of bread, right? So.
Is this a piecewise function or whatever it's called, or not?
This wouldn't be a p. It could be a piecewise because you got more than one equation. Yes. Okay. So, but so the only loads to meet all stipulations, the only kind of bread you have, those you can make is somewhere in here. And it would have to be integers too, because I can't imagine making 2.5 loaves of bread. It's not final. After something you made a loaf of bread, it did turn out. So, so questions on that? Now, what I do with this, so I say we're going to go a little faster in here. It means, usually it means when we go faster, it means less problems. Okay. So, like on this section, I believe I assigned, I have to look, Give me a look real quick here. Four through 52 by 4s.
What page?
Page 132.
Wait.
4 through 54?
4 through 52 by 4s. There's only 13 problems. Now, what I do is this. When I say we're going to go faster, like I told the other class too, I'm probably not going to hand out a lot of homework. You're going to be responsible to get it done, make sure you understand it. If you go through these 13 problems and say, maybe there wasn't a lot of word problems, maybe you should pick a few other word problems to try. Bring the class for questions. I'm going to put you guys in charge of a little bit of your homework too. I'm going to give you a minimal gig. If you feel like you need to do more, you know it very well after those, great. If you feel like you need more, do a few more. You decide how much you need to do. Don't just do the bare minimum if you don't still understand. 13 problems is not a lot.
What page is that? Is that 113?
I really like 113.
Graphics, so on.
So make sure you get those done as you go.
Yeah, do one.